what I have in this jar and bottle, it's not really tofu or feta, and you really shouldn't be eating this because it's highly toxic. This is sodium. Now you may be interested to learn that sodium, a very soft metal that's not very shiny right now, is actually quite benign when it's mixed with another dangerous poison, chloride. When you mix it with chloride, you get table salt. Oh look, I sliced it in half, and you can see, well, not in half really, in two pieces, and you can see that it's quite shiny on the inside. Why? Because this layer, this surface, has not been exposed to oxygen yet. Now oxygen from the atmosphere, from the air, will react with it really quickly, and it will lose its shine momentarily. You can already see that it's no longer as shiny as it was when I sliced it. So this is very soft metal. You can literally slice it with a pretty dull knife, as you saw a moment ago. But one interesting property of it is it's quite reactive. It gets quite excited when exposed to oxygen. So we already saw what atmospheric oxygen does to it. Now let's add some water. Okay, there we go, water. Now, trying this at home will probably result in a burned down living room. That's very inadvisable. There we go. It creates a pretty violent reaction. You can't really see all the smoke that it does in this video, but there is some smoke. It's probably quite hot, so trying to touch it probably would be another very bad idea. So what we have here is a reaction of oxygen. First, we have regular O2 molecule. So two atoms of oxygen bound together like that. This isn't a bind that's easy to break. That's why our sodium doesn't explode. But what we have next is something like that. H, H, O. H2O. That's water. These binds are much easier to break. That's why our sodium is way happier to come into a violent reaction in there. What happens whenever sodium reacts with oxygen? It creates something like that. In rare cases it would be Na2O2, but that doesn't really matter too much to us. Now, what will happen if we find a molecule that's like this? You may not have heard about this fella here. This is hydrogen peroxide. It's just like water, but with one more oxygen. That's where things get interesting, because these bindings are not very sturdy whatsoever. This chunk of sodium is probably a bit too big for that hydrogen peroxide. That's 12% hydrogen peroxide, serious stuff. Alright, and it should catch fire. Yes, it is catching fire, definitely. And one of the reasons why it's not wise to experiment in your living room, because, yeah, it will spray fire all over the place. Yeah, that's nothing to be concerned about. We'll get rid of it right away. We're prepared for that. But again, don't try this at home.